Hello, welcome to Retrospective podcast, where we have short, unedited, honest, unscripted podcasts with people from various backgrounds, including film, theatre, and science. And I'm absolutely delighted to be joined by Lawrence Krauss, who is a world-renowned physicist, founder of the Origins of the Podcast, and best-selling author of books like The Physics of Star Trek, one of my favourite books, A Universe from Nothing, and The Greatest Story Ever Told. Welcome, Lawrence. How are you?
I'm fine. It's nice to be with you virtually.
Thank you very much. One of the things I like about your books, Lawrence, is your ability to simplify subjects such as physics and science and make them understandable for laymen such as myself. And in particular, what I like about your latest book, The Physics of Climate Change, is firstly, you take out the politics, and secondly, you use a lot of graphs, charts, and images to sort of illustrate and back up the science. And I'm just curious, did you intend the structure of the book to be that way, or was it sort of an evolution?
I think, well, I intended right off to try and concentrate on the science. This is based on experience I've had with a lot of people, particularly a lot of people who are sort of not receptive to the idea that we should be doing something to address climate change. A number of them would just want to know that. I mean, there of course there are deniers who you can't talk to anyway, but the people who are willing to listen and are interested, a number of them don't want to be told what to do. They suspect it's a liberal agenda, first of all, and if they're not liberal, they're suspicious of government intrusion. And so rather than say you talk about the policies we need to enact, I thought it would might open their minds a little to reading the material if we just talked about the science. And the number of my friends who are of that persuasion, one good friend, Penn for example, was always said doesn't want to be told what to do, and he just wants to know the data. And so he was very excited and very happy with the book when it came out, and that convinced me that I was sort of reaching that way. I think, and the other point is that I think it's a necessary first step. I think too many people on both sides of the issue jump to policy without focusing on what the science is. I hear it on the left too. I hear people, making ridiculous claims about what climate change is and then arguing for policies. And I think that kind of chicken little attitude of the sky's falling doesn't help either. So so I thought, okay, it's a necessary first step to have rational public policy first to get people to know what the science is.
All right, brilliant.
The idea of the charts, it was an interesting question because it makes it extremely painful if you write a book with a lot of figures because you have to get permission to use all the figures and reproduce them, and it's a pain in the neck, and I often try and avoid it for that reason. But one of the things I wanted to do was, well, first of all, I think a picture in this case is worth 1,000 words. A lot of the data is just right there in your face. Although I'm also aware that a lot of people can't read figures, can't read graphs, and find it very confusing to see a graph. And so, that's a balance. But the other thing I wanted to provide for people, and I do it at this book by giving them a lot of resources at the end, is all of the graphs and figures have links, so they're all online at various points, and so I can refer readers to the places where they can go for more information, which is really an important thing to tell people that there's lots of resources. And while my book, I like to think elegantly introduces the subject and explains it in a basic way, that if people want more, there's access to it. So hopefully the figures will lead them to that. Um,
Right.
at the same time, when I write a book, I realize I try to reach all readers in a way. I try to produce material that will challenge people, and some people, are fine with it, and others are be challenged. But if you miss it, if you skip a figure, you don't miss the rest of the book of the story, if you wish, and or the narrative. And I do that with all my books. I think I want something there for everyone. So I want people who want the challenge to be able to have that challenge, but I don't want people who feel a little bit intimidated to feel that they're lost. And hopefully that there's a balance that way. Because what I try and do is explain the figures in the text, especially to people who have a hard time looking at a graph.
Yeah.
That's a long answer to a short question.
um, I really like the way that you begin the book and end the book, and it seems quite fitting in a sort of a profound way. And there was one quote in chapter one that really sort of struck me, and it's the Mekong Delta is a canary in a coal mine for climate change. Could you talk about what you mean?
Sure. Yeah. I mean, there are many reasons I began and end the book with that, with the Mekong Delta. One, because it's personal now. I led a group of people who were touring there a year ago, and it became very personal to me. But also, when we talk about climate change, tends to be in the abstract over there or in the far future. And the Mekong Delta, primarily South Vietnam and part of Cambodia, is is the perfect storm, as I say, for climate change, in the sense that it will feel the effects of climate change, the definite effects that are definitely going to happen this century, not the ones that are less certain, and it's going to feel it in an extremely strong way in the coming decades. And so here's sort of a certain immediacy that you get. These people, the Mekong River is one of the, and I have fun talking about it, is one of the richest freshwater rivers in the world in terms of the greatest number of fish. More fish are fished out of there than in all the rivers in the United States. And it also supports by flooding this incredible terrain of rice paddies, basically, that is the richest rice producing region in the world. And it does that by holding off the China Sea. And what is terrifying in a way is the realization, and this is relatively recent, that much of South Vietnam, 90% of South Vietnam, is less than 1 meter above sea level. And we're more or less guaranteed at least half a meter of sea level rise this century because of the effects of climate change, just due to the expansion of water, among other things. More likely, probably 3/4 of a meter. And most of South Vietnam will be below sea level by the middle of this century, or certainly the latter part of the century. And how that impacts, obviously, if the sea comes in, that area will turn brackish and there'll be no rice, and that's 60 million people are supported. But the river itself will be dramatically affected. And so now, as I point out, that's the future. Well, the future is the sea level is going to rise, but the future for South Vietnam is the future as it might be. Because what I wanted to stress in this book is not a doom and gloom attitude either. The fact is, as I also say somewhere in the book, the future is barreling right at us, but it's doing it like a freight train, but it's doing it on tracks that we've built. We can foresee what the impacts are, and we can try and stem them. I mean, much of Holland, 25% of Holland is below sea level, but it's not a bad place to live. But we need, globally, to recognize what those challenges are, what the realistic implications of climate change are, and I try and separate things in sort of the immediate things that we cannot stave off, the ones that are less likely, and the ones that are more speculative still, so we can adjust what policies we might want to enact. But I guess for me, the other reason it was personal is that this area is, if you ever go to that area of the world, Vietnam and Cambodia, which have experienced the most incredible hardships over the 20th century with war and genocide, and have come out of it with a remarkable attitude of no bitterness and friendliness and excitement and happiness, are now facing something that could be far worse, and it isn't even of their own making. And I think that's telling.
Yeah. We're talking about the future. You use a Charles Dickens quote, Christmas Carol 1843, which is one of my favorite Charles Dickens stories. I'm just curious, why did you use that analogy for climate change?
Because, I used it because I think it's really important that when we talk about futures, we're talking about possible futures. And the ghost of Christmas future was the future not as it will be, but as it might be, and trying to get the protagonist, if you wish, Scrooge, to potentially change his action so that future might not happen. And that's for me the most profound part of that story, or gripping part of that story, is when faced with that, and he says, "Is there anything I can do?" And I think it's whenever you're predicting the future, and as I often say, I don't like to predict the future in general, except for 2 trillion years in the future as a cosmologist, when it's much easier to predict, and also no one will be around to check. But when one's talking about these near-term predictions, I think it's really important to stress that certain things are written in stone and cannot be changed, but we can address them and mediate the problem. And other things are not written in stone and can be changed. And I think along the Dickens line that we're presented with that as a basically my book is it's maybe pretentious to say, but it's like the Ghost of Christmas Future. It's saying here's a possible future. Do you want to do anything about it? And if you don't want to, that's fine, but it's up to you.
Right. And in the book, Scrooge, of course, is able to erase the name on the tombstone. But are there things in climate change that are set in stone that can't be changed?
Yeah, well, I think so. I mean, of course, there may be revolutionary technologies that I can't that I think are extremely unlikely. But one thing that actually, no matter what we do, sea level rise. The sea level rises because water has been heated, and water expands when it heats. There's obviously two effects that go into sea level rise. One is the simple physical fact that water expands when it's heated, and I'll get to that in a second. The other, of course, is the melting of Greenland ice sheets and Antarctic ice sheets and glaciers, and those are accelerating too. But let's take the simplest one first. For people who don't trust the notion that Greenland is ice sheet is melting, even though I show data that's pretty convincing, you can't argue with the fact that water it expands in volume when it's heated. And the ocean has an incredibly long thermalization time. And we've already been dumping an incredible amount of heat, and we are. And over the last 25 years, as I point out, one calculation shows, the ocean temperatures increased by 0.0785 degrees Celsius, which doesn't sound like a lot, but it's a lot of water. And if you actually ask how much heat has been put in that water, it's the equivalent of 3.8 billion Hiroshima level atomic bombs,
Wow.
for a second every second of the day, 24 hours a day for 25 years. And that heat takes a while to thermalize in the ocean, and the air temperature, if you wish, rises before the ocean level does. And we've already heated the air up by a 1.3 degrees, and that additional heat is going to cause sea levels to rise by a quarter of a meter no matter what we do, essentially, before the end of the century.
Right.
I think, again, because the carbon we've put up there, the carbon abundance in the atmosphere will remain that way for almost 1,000 years. It's hard to imagine we're going to have less than 2 degrees Celsius change. Now, the only revolutionary technologies that might change those things that are written in stone are twofold. One, there's the possibility of carbon capture, but it's really, and I know Elon Musk has recently announced a $100 million prize for capturing carbon, but it's really a pipe dream at this point. I mean, a goal would be to have carbon capture cost $100 a ton, which we can't do right now from the atmosphere.
Right.
You can capture it from a coal stack, but that's where there's carbon. But if you want to capture it from the atmosphere, we can't do $100 a ton. But if you did $100 a ton, remember, we're putting in 10 gigatons of carbon every year into the atmosphere, okay? And that means that's $1 trillion a year just to try and take out what we're putting in, not reduce it, okay?
Right.
And although only half of it stays in the atmosphere, but I mean, you're talking an incredible investment money every single year just to counter it, if we had the technology, which we don't have, and if we could instrument something the size of Texas to do that. And so there's all these logistical challenges. So while it sounds nice, there may be technologies. In one of my podcasts with my friend George Church, who's a synthetic biologist, he suggested genetically engineering microbes that will turn more or less carbon dioxide into plastic, and then building huge structures out of plastic to sequester the carbon. Now, there's lots of interesting ideas. The other possibility is geoengineering, which says we put into the atmosphere aerosols that will basically reflect or absorb sunlight before it gets into the atmosphere. therefore reducing the extra heat load,
Right.
which could, in principle, cause counter directly the greenhouse effect of additional carbon dioxide. The problem is we don't know what the other side effects of aerosols are in the atmosphere, and that was one of the reasons I used to be strongly against it. But in fact, colleagues who are climate scientists have pointed out to me that the lifetime of those aerosols in the atmosphere is only a year or two. So even if the experiment went bad, it wouldn't produce
Yeah.
1,000 years of misery.
Right.
So there are possibilities that might alleviate even the immediate temperature rise. As I say, I think the ocean rise is inevitable, and similarly the things that go along with the ocean rise and temperature rise are melting of the ice sheet at a faster rate, which is certainly happening. And so the National Academy of Sciences puts a number like zero 0.8 plus or minus about 0.2 meters as sort of the likely sea level rise by the end of the century. So we're talking between a half and 1 meter, and I think that's if we somehow also have technologies that stop us from producing carbon or in the atmosphere within the next 10 or 15 years, or certainly by 2050. Otherwise, we're talking much higher temperature rise, and I think we're talking about definitely more severe effects. And I don't see any. I see signs that the global usage is leveling, perhaps, but not that it's turning down yet.
Okay. Okay. And just a follow-on question to that, you talked about the heat in the atmosphere, and one of the things you mention in your book, and it isn't mentioned much in the debate about climate change, is the upper atmosphere. And I've heard you use a quote about Las Vegas.
I coined that. I don't know if I said I call it the Las Vegas effect. What happens in the atmosphere stays in the atmosphere, and it's sort of roughly true. I mean, it's sort of each carbon atom doesn't stay in the atmosphere; it actually exchanges with the oceans and the land. But the abundance of carbon in the atmosphere remains constant for almost 1,000 years. It falls off maybe by 40%. So that's the real issue. I think that people on the right have to recognize. Some people on the right who say, well, look, carbon, I don't see any problems. Why should we do anything? And the answer is, well, it's true. The effects of climate change are gradual for the most part at this point. But every year we add another 10 gigatons of carbon, and there was only 600 gigatons of carbon in the atmosphere before we started this whole industrial process. There's now 830 gigatons. And if you want to stop the temperature rise at a certain level, then we can have, say, more than 900 gigatons of carbon, and every year we add 10 gigatons, and that means if we want to not exceed that goal, every subsequent year we have to cut things by a greater factor. That's why there's some urgency. It's not that in 12 years or 10 years the world is going to end, or your children are going to die, or some things that other people say. It's rather that every year we don't do something makes the next year harder. So if you want to do something, you just start now.
Right. Now you've taken on some big subjects such as the universe, which is quite big,
Pretty big.
physics and religion, and now climate change. And I'm just curious, which one of those have you had the most pushback from?
Well, it depends on the time and what I'm doing. I think I tend not to focus on the pushback very much, but I think I've had. I guess I would say that it's actually about equal in this following sense. The pushback in religion is people who basically object to the notion that science doesn't provide any evidence for God. Not the fundamentalists are all. There's always extremists, and those people you can't reach. Okay, they always push back, but there are other people who tend not to be extremists, but they somehow argue that science is compatible with the world's religions, and it just isn't. Okay, and so that I get pushback from them. When it comes to the universe, there is a lot of pushback from people who don't like the idea that the universe could come from nothing without any forget whether you believe in supernatural shenanigans, but that spontaneous universes can be created, and they don't like the notion of nothing, and one has to talk about that. And I get into endless or I have gotten in endless debates with people who like to define nothing in a different way, so that the universe can't come from it. Whatever, that's their definition of nothing. But in fact, for all practical purposes, the universe can come from nothing. But I guess what surprised me, now that I'm speaking out more in the context of my book, I've always talked about climate change in different contexts because I have many different hats. I was chairman of the board of sponsors of the Bulletin of Atomic Sciences for many years, and that was an issue there. But now that I've written the book, I'm really surprised at the strong pushback from people who deny, who claim that the science is fraught with uncertainty or wrong. And the point is, it's basic physics. It's 200-year-old physics, and it is not, the detailed models of what's going to happen to the Atlantic currents and stuff that may require computer models, but the notion of energy in equals energy out, if you don't want the temperature to change, and how carbon dioxide produces absorption in the atmosphere and ultimately produces what's called radiative forcing, that's pretty basic physics. And I'm amazed at how many people refuse to accept that basic physics as trustworthy, or refuse to accept any evidence, in spite of all the graphs that I show, that there's been any significant evidence of climate change. And then the last set are the people who say, well, that evidence of climate change isn't unique, in spite of the fact that when you show the curves, it is unique over the Earth's history. We haven't seen that kind of change, at least in carbon dioxide, in a short time, ever in certainly in the last million years of the Earth's history.
All right, brilliant. And what are some of the biggest misconceptions about the physics of climate change?
One is that the physics is uncertain. The modeling, of course, is modeling the atmosphere that's uncertain, but the underlying physics is quite well understood. And it's, as I say, it's basically nothing more complicated than energy in equals energy out. If the energy in is greater than the energy out, what do you think happens? There's more power coming in, more energy coming in. It's got to go somewhere, and that goes into heat ultimately. And where that heat is distributed and how it's distributed among the Earth's surface and the oceans, that requires some modeling. But the inevitable fact that which you can measure, that more energy is coming in than going out, it is straightforward. I think the other misconception is that because the effects are not necessarily dramatic now, that you don't need to do anything now. And I talked to you earlier. I think that's a misconception, because it doesn't treat the fact that carbon that we put up there remains up there. Right. I think there are other misconceptions. I get them all the time, that somehow carbon dioxide, which is 400 parts per million, 0.03% of the atmosphere, that something that's so small in the atmosphere can have such a big effect. And I've given lots of analogies for how something can have a big effect, and people send me in new ones all the time. There's lots of substances you can drink at the part per million level that will kill you, and so parts per million certainly can have an impact, and carbon dioxide does. We can measure it. I think the notion that I think another misconception is the realization that really the greenhouse effect isn't a greenhouse like a normal greenhouse. It's as I talk about. And in fact, much of the action is taking place at the top of the atmosphere. That's where the Earth is radiating into space, and that's what's balancing the energy coming in from the sun. And so what's really happening is the increased carbon dioxide in the atmosphere is making the atmosphere more opaque up to a higher level, and therefore radiation can't escape until you're even higher in the atmosphere, and that's a colder level, and the Earth radiates or any hot body radiates as the fourth power of temperature. So if you're radiating at a higher level where it's colder, you're radiating less. I think the fact that a lot of the action takes place at the top of the atmosphere, not the surface of the Earth, is probably another misconception, I guess. And the last one, I think, is the notion that somehow humans can have an impact. We just seem so small compared to the Earth. And again, there I use the example that the first person to realize that you could have an impact, in my mind, was remarkably in 1894, a Swedish geochemist, Arvid Högmo, who did the estimate: take all the carbon in the atmosphere then and turn it into liquid. How thick a layer would it be on the Earth's surface? It'd be 1 millimeter. And of course, clearly life is exploiting the surface of the Earth much greater than 1 millimeter. and then humans are exploiting it much more by extracting out 50 million years of life through fossil fuels. And so it's the fact that life in general can impact on the atmosphere it should be obvious from that estimate, and the fact that human industrial activity can have an effect is a natural corollary. So those are some of the big misconceptions, I think,
Right.
that one needs to overcome.
In a world that's lost the art of listening, how do we get people, governments, corporations to discuss, debate, and act upon such an important issue of climate change?
Well, look, I say in the book, I think, but I certainly say in public a lot, that governments don't lead, they follow. They rarely lead. They follow when there's a public consensus that pushes them forward. And so one way to get governments to act is to get people involved and interested. And one way to get people involved and interested is to educate them. At least that's my feeling, and that's why I wrote this book. And I wanted to provide people, not just the skeptics, but the people who are seriously concerned with data and information they can use. All of us have soapboxes that we can talk to our family, our friends, going to our kids' schools or churches or whatever, and we can impact others. And if people are interested and show that interest in the ballot box, then governments will act, I think.
Right.
Interestingly, with corporations, I think they already, a friend of mine, my friend Noam Chomsky used to say to me many years ago that if you want to see what the world really happening in the world, read the business pages, read the business magazines. Why? Because they want to make money. They have to know how the world really works. They can't live in the fairy tale world and actually be successful. So I think businesses are already moving with their feet, and not just businesses, but if you really want clear evidence that climate change is an issue, look at the military. The military the U.S. military had a climate change security task force well before anyone else did, because they realized that it's a potentially huge security issue, socio-political issue, if there are tens of thousands or millions of climate refugees, for example. And so I think you already see the military and businesses in many ways voting with their feet. But of course, public pressure will expand on that. I mean, if as this happens, I'm not always in favor of these things, but there are movements to have, universities and other big institutions to take fossil fuel companies out of their stock portfolios and things like that. That's one thing. But I think the fossil fuel companies already realize where the future lies, and are looking at battery technologies and other things, because that's the future. And it's, that's the interesting thing. We can debate coal all we want as a production, but it's already dying. It doesn't really matter. It's dying anyway, and it's great, and we should help it die. But it employs very few people, and it's economically not particularly viable, and it's incredibly dirty. And so you see, a lot of this is happening on its own in any case. But to the extent that the public, through their interest, can accelerate that, that's great. And so I know how that when you, as an individual, you feel kind of impotent in this way because it's so big. I feel that way often when, the example I like to use is when I go in the voting booth. I feel like, well, my vote, what's it matter, But all those votes add up, and eventually someone gets elected, and each of us can do many things on our own. And if we all try and do what we can do, then we can make the world a better place. And part of what we can do is at least inform ourselves of what the issues are, and to help inform others.
Okay, brilliant. Are you optimistic or pessimistic about the Earth's future?
That depends on the day. I mean, really, it does, and it depends on the time of day. But I mean, I'm pessimistic about the fact that humanity does not seem to be able to, has not yet recognized the need to act globally, whether it's nuclear weapons or climate change. At the same time, I'm optimistic for two other reasons. One, I think technology is incredibly important, and we can develop technologies that'll mediate, if not overcome, climate change. And so I think there's a lot. The problem there is not technological; it's political. But the other cause of my optimism is a generational one. That recently I've repeated this a lot, but it's nevertheless true that the physicist Max Planck used to say physics proceeds one funeral at a time, meaning eventually the old guard die off and the new young people who are doing new things take over. And we can see that I think the next generation is already much more attuned to the notion that human-induced climate change is an issue. And we saw it with gay marriage. In less than a generation, I mean, in an almost unbelievably short time, we went from a point where it seemed impossible that gay marriage would be legal to the point where it was no big deal. Why? Because the younger generation all had, my daughter's age, had friends, were gay and openly gay, and it was no big deal. So it didn't matter what the older people in the Senate or Supreme Court or whatever were doing. Once you have a new generation, it changed. And so one can get great change in a single generation and so I think that's why it's important that we sort of educate the next generation. And the sense I already get is that the younger generation is concerned about this. So that's a point of optimism at some level. But it's a long struggle, and and uh, and I think false optimism is not the best way. But neither is putting your head in the sand.
Right. Brilliant. Brilliant. So I'd just like to end the podcast with on a fun note. I'll just ask you some very quick fire questions.
Okay.
What is your favorite equation and why?
Well, let me start saying, if you ask a lot of these questions, I have very few favorites. People always ask me to hierarchy list things. I just
Right.
don't think about the world that way. I like a lot of things, but I very rarely, there are a lot of things I like, but I rarely, apples and oranges.
Yeah.
So I try not to compare them. But one of my favorite equations is Einstein's equation of general relativity, because it's a beautiful equation that relates matter and space, the fundamental aspects of the universe, in an incredibly elegant and concise form, but incredibly subtly difficult to the implications of it are profound and difficult. That's one. I think
Right.
another equation, which is an equation of physics but equation of mathematics, is my favorite, is e to the I pi equals -1, because it has all these, it has imaginary numbers, it has pi and e, two transcendental numbers, and it sort of relates them all to -1. So I like that equation because it relates three vitally important quantities that all describe nature in a fundamental way: e, and pi, and I, the square root of -1.
All right. And last question. Maybe this isn't a fair question. You do the Origins podcast, but what has been your favorite interview thus far?
Well, again, you know my attitude towards favorites. I've liked every interview I've done for different reasons. It's almost like asking my favorite book. Usually, my favorite book is the one I've just written because that's the one I'm involved in. I really enjoy the contrast. I've been very fortunate in the guests we've been able to have. I have a broad group of acquaintances and other people who agree. So, I mean, take the first two podcasts we did, which were Ricky Gervais and Noam Chomsky. They were completely different, but in my mind, equally phenomenal in different ways. I've loved, and I love some of the science ones that we've done in detail. My friend Shelley Glashow, Nobel Prize-winning physicist, a wonderful history of sort of particle physics over the last century. Stephen Fry, I could just
Yeah.
listen to him read the phone book for hours, so it was fairly important. And actually, the most recent one that came out with Ian McEwan, who's a friend. It's just,
Right.
which I'd done that interview a long time ago, and it's just wonderful to listen to. He's such an amazingly articulate and thoughtful man. So I think what I particularly like is when I can get the combination of art and science together in one place. When people realize that science is part of our culture, that you don't have to be a scientist to be fascinated by it. And people like Ian or Stephen Fry or even Ricky Gervais who are fascinated by it are great examples of that. And I'm going to be doing an interview with another well-known cultural icon in a week or two, and you can wait for
Oh,
that one.
brilliant. Okay. All right. Well, thank you so much, Lawrence. I'll just talk to you after the podcast. Thank you very much.
Well, thanks. It's a pleasure. Thanks for the questions.